So the next thing we're going to do is jump into kind of a crash course around TypeScript and how we would add types to modern JavaScript. At a high level, we're going to talk about variables, ordered data structures like arrays and tuples are just a specific kind of array. We'll talk a little bit about objects, and then the equivalent of the logical and or operator in types. So we call these union and intersection types, but they will remind you a lot of and or. So we're going to switch away from the slides here, but if you want to follow along, there are a bunch of files in the notes folder of the exercises, of this workshop project. And I've done this deliberately so that you can hover over things and look at what the tooltips say and kind of poke around at it. So feel free to do that as we're discussing, because your editor is going to give you a lot of feedback about what's going on. And I'm going to walk through and uncomment things step by step so that we can kind of learn about how TypeScript works incrementally. Notes 1. Here we go. So first, let's look at point number 1 here. This is just a regular JavaScript statement, right? It is a variable declaration. That's what we would call it. Like, I declare that X exists. It's a let declaration. Anybody know what makes this different from a const declaration? What's the difference between let and const?
Reassign.
Reassign. So let can be reassigned, const cannot. The type of X ends up being string. That's what our tooltip tells us. And that makes sense because we're initializing it with a string. You don't really have to do too much work to understand that. What we're seeing here is inference. We don't have to type absolutely everything in our app. In fact, it would be a bad idea to do so. You kind of end up typing yourself into a corner. You make your program very, very rigid if you type every single thing. So just like any let declaration, we're able to reassign it without running into any trouble. X equals hello Mars. The new thing that TypeScript is throwing at us is we get an error here if we attempt to assign it to a value that's not of the correct type. And the error we're getting is 42 is not assignable to type string. This is obviously telling us that there is a mismatch of some sort. And we'll explain why this 42 is here instead of a number in just a moment. Or instead of the word number. So let's look at the same example, but with a const declaration. The type is different here. The type of Y is literally the string hello world. And the reason for this, the reason that we can make this type so much more specific, and it's specific because it's not just, this variable cannot hold any arbitrary string. If we think of types as sets, right? It's like buckets of allowed values. Our let declaration, that variable could hold any string. This can hold specifically a string whose value is hello world and no other string. If we tried to change it down here and set it to, well, if we tried to reassign it, we'd run into a problem in general because it's a const. But if we tried to pass it into a function that wants hello Mars, we'd run into a problem here saying hello world and hello Mars are not compatible, right? So this is what we would call a literal type. And that means you are enumerating a set of allowed values, specific strings, specific numbers, something like that. And you really can only pick from one of that set of options. Now this is TypeScript being specific because it can. And it makes us kind of want to revisit the let here. So if the let declaration were to take on a value, if that variable were to take on a value of whatever string we initialized it with up here, we would have run into trouble in reassignment, right? If it were, instead of calling itself string, if it were to say hello world, now it's like set itself up to be way too specific by default. So this is one place where TypeScript's trying to be as useful and strict as it can without getting in your way. When you're dealing with a value that's not reassignable and the value itself is immutable, like we can't change the string, we can't reassign the variable, it's set in stone, we can be maximally specific there. We'll see this come up a couple times as we explore different things. Yes?
I have two questions. One of them is simpler. So when the tooltip shows up with the comment, is that a feature of native TypeScript or is it a feature of TypeScript's compatibility with JSDoc?
When we see the comment pop up?
Yeah.
So you're asking about this down here. Good question. So it's actually, you said, is it a feature of native TypeScript or a feature of JSDoc and the editor? Mm-hmm. Right. Kind of both. TypeScript can understand those comments, and the language server is actually pushing that comment data up to us. So at the end of the day, when we start playing with the TypeScript compiler API, we're going to build a quick and dirty documentation tool, and you'll see that in addition to parsing the code, in addition to parsing the executable code, the inert comments come along with it, and we can actually even grab JSDoc tags. So comments aren't entirely inert in TypeScript. There are certain things you can do that will affect the output. One example would be if we did internal. This was recently added. This is a special JSDoc tag that will mean even if this was exported, leave out the type information. We may export it for the purpose of testing this value. We might want to import it in tests. But your declaration files, those .d.ts files, those won't have anything about this specific type, or this symbol, not a JavaScript symbol, a TypeScript symbol.
Cool. And then the other thing I was going to ask was, so for declaring with const, and it's like an object with keys defined, obviously oh, you're getting there.
Great question.
Cool.
Sorry to cut you off there. I just know exactly where you're going. So let's try this a different way. Const y_obj equals. So same deal, right? We have a const declaration whose value is an object. It's going to take on the type just as it did. Now note that the value of, the type of foo within the object ends up being string. Why? Because the object is mutable. Const can't be reassigned, and that means we can expect the property names in this object to, we'll want them to remain what they are. Like, the assumption is you set this up deliberately, with the properties you wanted there, and if you wanted to add additional properties, you'd have to give TypeScript a clue about that. But we'd be free down here in JavaScript to do y_obj.foo equals by. That's totally allowed. And if TypeScript would have taken on the literal value hello as the type, right, we wouldn't have been able to do this neatly. So again, it's trying to stay out of your way, but being as strict as possible within those bounds. So let's look at separating variable declarations and initialization. So often we need to do this. One place I can think of that I do this is if I have a variable that takes on a different value based on some conditions. Maybe I have like a case switch with 5 or 6 case clauses, and I want to set the value of something based on which of those clauses I fall into. I'll probably declare that variable outside of the switch statement and then assign it in each of the clauses. So you end up with something like this, but we run into something that looks a little bit troubling here. We initialize it to 41, or we assign it to 41 because it has no initializer. And then it looks like we can use a string as well. And this gives us a clue as to what's going on here. Z takes on a type of any. It's basically a wild card. TypeScript, well, type systems in general call this a top type. Top types can take any value. And it's not that these are evil. They just play by the same rules that JavaScript variables play by, where we can flip-flop between strings and numbers and arrays and functions, and it'll take on whatever you want. So it's a point of weakness in your types. Now, there are places where it's totally valid to use an any. So don't think that you're on a mission to completely purge them, from your app. You just want to make sure that wherever you have it, you actually want to allow absolutely anything. So we could improve the situation if we wanted to by, in our variable declaration, specifying a type. And this is called a type annotation. We're sort of attaching a little extra piece of information to the variable that says, look, you don't have an initializer, but I'm telling you, number is what you are designed to hold. And now we get our desirable type error if we try to put a string, into this variable. So this is something you got to watch out for, right? If you have declarations where you don't initialize the variable, you're going to want to specify what type this is designed to hold. Yes?
So in the official docs of TypeScript, they generally do that type declaration as even if you're initializing the variable with a value. Is it recommended to do it that way or no? Or does it not matter?
That's a great question. I would say it's recommended to do that way if you're writing docs because you're being very descriptive in documentation. And what's more, I'm sure the TypeScript team would love to have the ability to show tooltips in their docs where you could hover over things and see what they are, right? So like in this example up here, describing that this is of type hello world, like to write that out in text, you might be verbose in doing so for descriptive purposes. But because we have an editor here, we don't have to do that. I err on the side of providing type information in a few specific places. Variables with initializers, not one of those places, because TypeScript can always infer at that location. But I'll be very clear to point out spots where I always put type information as a way of kind of setting deliberate boundaries around pieces of code. Or basically, what I'm trying to do when I provide type information is provide an explicit contract between two things and keep myself honest on both sides of that contract. But here it would just be extra stuff. But I would write my docs in the same way, to be clear. Let's touch on arrays, right? So we've been working with primitive values so far, and through questions we got a couple object examples. So here's an example of an array, and pretty intuitive. Like one way of representing an array is to use square brackets following a type, right? So this is an array of numbers. We can push 33, and as you would expect, trying to push a string into this array will cause a problem. Now, if we didn't have this here, we would run into issues. That's an array of nevers. Sounds bad. Array of nevers, as in it can never happen. It's never going to work. So never is TypeScript's bottom type. And we will look at that more in detail later when we're studying top and bottom types specifically. But just note that we're going to have problems pushing anything at all into this. And if we think about it, this kind of makes sense. Like if you could only look at line 57 and you had to decide the type of AA, all you can assume is that it's an array of whatever. It's an array of something. Now you could say it's an array of anything at all, but that's going to be dangerously flexible, right? So an array of nevers, yes, it's an array, but without additional information, TypeScript doesn't have what it needs in order to make a nice, safe choice for you. So that's why for array declarations that start out as empty, you want to be specific about what you're putting in there. Now, if we had even one element, it's going to be able to make a reasonable assumption here. So if you didn't have motivation to, like, in situations where your array starts out with something that'll definitely be there and then conditionally you add other stuff, putting that in the declaration itself as the variable initialization, now you have motivation to go and do that, because it saves you from having to actually specify that type. It can be inferred if you give it some contents at all. So tuple is a fancy word. It just means array. It's an array of a fixed length, and an array that comes with a convention. So if we were to define a data structure that could contain a street address, we could use an object with property names like house number, street name, postal code, city. And then we could pluck things out as we need them. Tuples similarly can hold a structured set of data, but we just have to remember that the convention here is the first thing is the house number, the second thing is the street name, the last thing is the postal code. And we still get strong typing there. So these arrays can only be of length 4, and the types of their members must be exactly as we declare them. Now, this is a great way of returning multiple values from a function. Like, I was successful in making this fetch, and here is your data. I was unsuccessful in making this fetch, and here is your error message, right? A nice alternative if you have something that through regular use might throw. You know, instead of throwing, which is good for exceptional errors, things you didn't plan for, this would allow you to return like a thumbs up or thumbs down for the result and data about the details. You can see here that we get type checking for members of a tuple. One thing I want to point out that may get tightened in the future you get type safety around the members, but I believe you don't get type safety in push. So it's going to regard this as, in terms of the type of push, it can take strings or numbers. So with tuples, you're going to want to be careful to just sort of set its value and access its value and not use the array methods because they're not really type safe. There's actually no way to safely type push in such a way that based on the number of elements it currently has, like if we were to try to incrementally build this up, we wouldn't know like that first we should accept a number, then we should accept a string, then we should accept a string, then we should accept a number. That would require us to kind of, based on state in the array, change the type signature of this function. And you don't use tuples this way anyway, because the only way to get a valid one is to like set it all at once, and then that can all be type checked as a whole statement. Yes?
If you did, for example, want to have an array that could be either a number or a string, how would you go about doing that?
Good question. If I showed you this tooltip here, it's wrapping in a, oh, wait. Sorry, it's this tooltip. So this is kind of an example. If you had to read that, like how, can someone give me a shot at string or number? It's string or number, parentheses, and an array of them.
So you could do like a string in a function, like I want an array of strings or functions to return back in this or something
Correct.
like that? Okay. Cool.
And that's the last thing we'll cover in this
sorry.
section. No, do not apologize for leading us up to those. If anything, you're doing me a favor in teeing up the next sections. Other questions about this?
You can actually just put any, like declare it as an
Totally. Yep, you could do any. You can always provide a type annotation to loosen things up. Similar to our let and const example, when creating these tuples, right, these things of fixed length, like a pair of numbers in an array, you're going to often have to, or always, have to specify the type you want. Why? Because erring on the side of not interfering with your workflow, TypeScript's going to consider this to be an array of numbers, right? It's not going to consider this to be a tuple containing 2 numbers. So you just have to always provide this type annotation here because it's a pretty specific thing. Same goes with a string literal type. If you wanted a string whose type was only the string Mike, it wouldn't be enough to just say let x equal Mike. You'd have to say let x colon Mike equal Mike. And only then would you get that really, really specific thing. We've already touched on objects a little bit. Object types here, they look kind of like object values, except instead of key value, you have key type. I use prettier to format my code, which is why I get the semicolon here. I like this because looking at this, the fact that there's a semicolon, it's one more thing that helps me understand this is not a value. This is just a type. By default, all properties are mandatory. So we get an error here saying street name is missing in type house number. Well, I've got an example of the error down here. Street name is missing in this, but it's required in type that. And I want you to imagine this as TypeScript at that equal sign trying to figure out a way to make the left-hand side and the right-hand side agree in terms of like, are these types compatible? On the right-hand side, we just have house number. On the left, street name. So that's why you're seeing the error message represented in this way. If you really wanted to make something optional, and this is not a bad thing, I typically use this if I have a function that takes a big options bag, right? Big options object. Just use the question mark. Question mark's like it may be there, it may not be there. And you see here we don't run into that problem. We could totally add it. I need a comma. Street name, there it is. Say it's just street name is empty string. It's a pretty exclusive address. But if I wanted to have another thing there that's not present on the type, I'd be busted for it. There is no X. Why would you put it there, right? We'll go into interfaces in pretty deep detail. For now, I just want you to think of an interface as a name for one of these structures that we're creating, right? For now, you can think of it as only working with object types. There are other things we can do to make it work with things like functions. But all we're doing here is we're creating a name address that we can use anywhere that we were using a type before. And you can import and export interfaces from modules just like values. The and or operators. So I've created 2 types here. And one is called has phone number. One is called has name. They have something in common and they have something that's different, right? So think of this as like a Venn diagram, right? They both have name, but one has email and one has phone. So here I've created a piece of code that basically rolls the dice, does a math.random, and half the time it's going to initialize it to has phone number. Half the time, it's going to initialize it to has email. And in fact, TypeScript should be able to figure out, well, unfortunately, that's why I left that there. It's the same type, but it just makes it ugly, right? So here we get the nice names, has email or has phone number. Removing that, okay, I mean, that's kind of accurate in a way, but like, not really what I was after, and way more verbose. So note that once we have this contact info variable, we can only access name. So think of this as like if you have this sort of Venn diagram, and it could be one side or the other. We're looking at the intersection between the two. We're looking at sort of that lens. We can only access things that are guaranteed to be there. And regardless of whether this is a has name or a has phone number, name is going to be there. So that's why we can access name and only name. Union types, they use this and operator, ampersand or and. And this is saying effectively, other contact info is both a has email and also a has phone number. So it must be initialized so with everything these two shapes have. The union, this would be the full Venn diagram, both bubbles. So if we were missing one thing, it would say property phone is missing. And because we're guaranteed to have all three of these things, we can access all three of them, right? There's no ambiguity. There's no either or. It's definitely both. So, and this, sorry I left that there. That was an example from a previous run. So just to recap here, we covered variables. We looked at how TypeScript could infer the type of a variable through it being initialized. We looked at arrays and tuples. Those are the ordered data structures. One, the array, is of arbitrary length. The other, tuple, has a fixed length and a specific type for each element in the tuple. We looked at object types, and really the only thing you have to remember there is question mark means optional. And then finally, the equivalent of or and in the type world, the intersection and union operators. The next thing we're going to talk about is a little 5-minute description of type systems and how you can tell the difference and take advantage of the difference between something like TypeScript and something like Java. So type systems come down to this question of type equivalence. And that is the same thing we were looking at when we saw some error messages that related to the left hand and the right hand of an assignment. Right? That's TypeScript trying to figure out, is this value you're trying to assign equivalent to this type of the variable you're assigning it to? And the same thing happens when you're trying to pass an argument to a function. Just think of it like an object trying to pass through a hole. You want the square peg passing through the square hole as appropriate. So really it's about, can we regard X as an HTML input element? Nominal type systems like Java and almost every typed language out there, they would answer the question based on whether X is an instance of a class named whatever the type you're looking for. So this would require you to have all of your code set up in a fairly object-oriented way where you have constructors and you're dealing primarily with instances of classes and you're passing things around. This isn't necessarily how JavaScript code is written. And this would require us to do a lot of rewriting and to make almost everything a class and an instance in order to have factories with specific names so that we could take advantage of types. TypeScript is a structural type system. They only care about the shape of an object, which is property names and types that are allowed for those properties, right? So it only cares about the structure of an object. So if we had a data structure for a car, we could call it car, but really all we care about is the fact that it has properties called make, model, and year that are of the appropriate types. Same goes for functions. We really only care about the arguments and the return type. And if you create a totally different function that meets those criteria, you can, that will end up being type equivalent. That will be usable where you need that type to be used. And I should point out that this is an important concept to understand in TypeScript, but also if you have consistent shapes in JavaScript and you avoid introducing new properties to objects that have been heavily used, you end up having a better shot at JavaScript runtimes like V8 optimizing your code. TypeScript uses the term wider and narrower to describe a level of specificity. And you'll no doubt come across someone who uses wide and narrow, and I'm going to start using these terms today. But here's a diagram to help you understand what we mean by this. The widest type is any, and it allows for any possible value. And just think of it as like the set of allowed values for any is infinitely wide. It can just take absolutely anything. It's almost infinity. Now, if I said I want an array, any array at all, I don't care what type of value is in this array, that would be a narrower type, right? We're not infinitely wide anymore. The set of values, if you line them up end to end, it would be narrower. Still pretty wide though. And we could get even more specific and say, this array can be of arbitrary length, but it must only contain strings. And then you could say, but it must be of length 3, but those strings can be anything at all. And then we could get narrower still by being very specific about what certain strings these values might be. Now, if we had a function that could operate on any array, we could look at the array type, and anything below it, anything narrower than that, will be fine to use. It's just more specific. We can always regard an array of 3 strings that must remain of size 3. We can always regard that as an arbitrary array of strings, or as an array of anything, or as any value, right? So narrower values can always fit through the wider whole. That's the way I kind of think of this. But if you wanted to have specifically an array of strings, and you had an array of any, you'd have to find a way to narrow that type and to validate that only the correct thing fits through. So this is what we mean by wider and narrower. Wide is very general. Narrow is extremely specific. We ran into this never type when we were initializing an array with an empty array. Never is infinitely narrow. It literally can hold no value. I mean, it can hold a never, but that is like circular reasoning, right? You think of it like there is no hole. Nothing can really pass through. It is nothing and impossible, or unreachable. Think of it that way. The next thing we're going to look at is functions and function types. So look in the notes folder. This is the file that starts with the number 2, function basics. So I have a function here called send email, and I have an argument here called to. And what I'm using here is has email. And if I do, at least on a Mac, command click, that'll take me to this interface from the previous notes that we were going through. I exported this interface from the previous module, and you can sort of jump to the definition of this type. So I'm going to be kind of reusing things as we go along, but this points out that we can import and export interfaces and types just like we can do with values. This is how we indicate a return type, and it's actually the same convention we've been using for variables. It's colon followed by a type. And this is an object that has 2 strings, recipient and body. And here we're just building up that body to send apparently some spam email. So this is a place where I tend to always use type annotations. And this is because I want to define the contract that this function has with other parts of my program. TypeScript can infer return types pretty well, but it's very easy to slip up and unintentionally change things, which I'll demonstrate in a couple of minutes. This is the arrow function flavor of basically the same thing, and the only difference is you have the fat arrow. So it's the parameter list colon type fat arrow implementation, right? Parameter list colon type and then the fat arrow, and you'll get used to that. So return types can be inferred. This is a function that will take a contact, and in terms of what this function needs, it may typically operate on things that have way more than just the property name. But I'm being conservative in terms of allowing this to operate on any object that has a property name. When I'm typing function arguments, I kind of want to state the minimum thing I need in order to avoid over-constraining the function, right? This might be useful elsewhere, and I don't want to artificially impose additional requirements on what these arguments must be. I want it to be as flexible as possible. And what's happening here is we split this string, contact name, we split it by white space, we throw if there are less than 2 parts, and then we return an object where the first part is the first name, the last part is the last name. The middle name, if we only have 2 parts, ends up being undefined, or we join everything in the middle together. So if we look at the return type here, there it is, oops, and we can see that it is correctly inferred, right? So the compiler is going through all possible paths of this program, and it's figuring out, what all is possible to return here. If instead of, so like let's say we had this function, and at some point we need to handle the Madonna case, or the Prince case, where it's just a mononym, right? There is no last name. So we would then go up here and say, if parts length equals 1, instead of throwing, we can just return, return name parts 0. So now we've added an additional possibility here where now we return an object, and TypeScript's tried to impose some consistency here, but we've returned something that potentially has an undefined last name. In fact, all of these values will end up being undefined. So I may not have intended this to work in such a way, and this may affect other parts of my code. So I like to specifically state a return type because it keeps me honest within all branches of this function to make sure that what I'm returning is intentional. Sometimes you early terminate, right? Like if you determine that this function that was just called, it's a no-op now. And early terminating, what is that? If I just say return semicolon, what am I really returning there? If I invoke a function and it just says return semicolon, what value do I get? Undefined. So that will change what this function, it will change the type this function returns, and that sort of has a ripple effect through your code. And I would rather keep that boundary very deliberately created and operate on both the inside and the outside of the function to make things work. So REST params work just like you'd expect. Nothing really interesting here. The only thing you got to be aware of is the type of a REST param has to be array-like because it's going to be consumed as an array. This part is particularly interesting. Overload signatures. So we have a function here called contact people. And I take in an argument called method, and the type of method here is either the string email or the string phone. And then any other parameter that follows can be either has email or has phone, the same types that we were using in the last exercise. So down here, let's make sure that that this works as we'd expect. If I want to contact people by email, I can do this, and that's an invalid email address, but from a type perspective, it should work. This also works. This should not work, right? Email, conceptually, this makes no sense. If I'm trying to email someone and they only have a phone number, we're going to run into a problem. And unfortunately, this currently works. And the reason is we have defined 2 independent and unrelated constraints here. It can be either email or phone, the string, and then the objects that we take can be sort of a mixed bag of contacts with emails and phone numbers. So although these are the narrowest types we could provide for these 2 arguments in order to get done what we need to get done, there is some disallowed combination that we want to prevent. and TypeScript provides a way of doing this. So I want to look at a tooltip here, contact people, and this matches exactly what we're seeing above, right? The first argument is one of our two special strings, and then this is our mixed bag of has email and has phone number. What I want to do is create two additional function signatures. Sorry for that little jump there. And these are specific, valid ways to access this function. So the first one, you can only pass in email, and then you must give me a list of people with email addresses. Second one, only phone, and then only has phone number. If we look at our tooltip now, see that little 1 of 2 and 2 of 2? There are two specific ways that we can invoke this function. Either specify the string email and give me objects with an email address, or let's get a line with the string phone and has phone number. And if we look at our third and problematic example here, it's telling us that we've provided an object with the phone number. So this, either I have to change one thing or the other, right? It's currently erroring by saying, you got to make this string phone. You're operating on people with phone numbers. I don't have email addresses. So note that we have two ways to access this function, and those are the specific function signatures we've defined up here. This is not callable from the outside. It just needs to be wide enough, general enough to accommodate all of the function signatures. So if I were to remove this, we'd run into an error on the phone signature saying, the underlying implementation does not accommodate passing phone as the first parameter. So it just has to be general enough that it'll meet the needs of all signatures above it. Yes?
So could you just safely remove the type signature from the actual function call?
It depends what you mean by safely. So you could still, from the outside world's perspective, it would be exactly as safe as it is right now. And I think what you're saying here is basically string and make this like an array of any's, right?
Or even just removing everything, all the types from line 53 to 56, because we've got the declarations on 49 and 50 already.
Totally, and these would become what we call implicit any's. So this is going to be an array of any's, this is going to be an any. And from the outside world, because we can't actually access the signature, no type checking from the outside world ever is compared against this signature. So the outside world won't care. But within this function, I'm in the Wild West here. Within the function, I don't have any kind of type safety. So it's a good idea, for the purpose of maintaining this function, to not be super, super general. You might do something like this, especially if you end up creating a whole bunch of these signatures here. Let's say we had fax and SMS and smoke signal and, it starts to get to a point where this becomes a difficult to manage type. And I might fall back to string here, right? Good questions, everybody.
Quick question.
Yes?
So the overload signature is a documentation strategy?
No. Well,
It seems kind of like one.
it has documentation benefits, to be sure, because it's very clear to consumers what they should be doing. But I only say it's not purely a documentation strategy because it actually has type checking ramifications. This signature on line 72, this attempt to invoke the function here, this is not type checking because we only allow A and A, B and B, and this signature here is trying to do A and B. It is like a disallowed range of arguments that we can pass in. So more than just providing useful tooltips, it is actually greenlighting certain styles of invocation and forbidding anything else that doesn't fit. Has anyone here ever worked with a language that supports pattern matching? like Scala or Erlang or Elixir. So this is similar to patterns, where like often you can define multiple signatures that are designed for specific cases. The difference here is you can only have multiple function heads. You can't have multiple implementations, right? Where you couldn't have multiple behaviors here, like independent functions that share the same name and kind of stack on top of each other, just the signatures. And the reason is this has to become JavaScript, and this JavaScript doesn't support like patterns in that way. But I think of it in a similar way. JavaScript has this thing called lexical scope. Lexical scope just means what is the value of this when you invoke a function, right? This is important if you deal with building something like a single page app and you have components, and those components have things that are bound to DOM events. You need to make sure that your events fire in a way that allows you to access stuff on your component to make things nice and convenient. So this is actually part of a function signature. So if you're defining a function, and usually it's going to be like a function that's outside the context of a class, right? Because classes already kind of handle this for us. But if you're going to really depend on being able to do something like what we're doing here, we need the value of this to be correct. So you only need to put it in your function signature at the very beginning under it's like a pseudo parameter called this. And type checking will be done to make sure that everything looks okay. So I'm going to create an object that kind of meets this constraint so that we can explore how this works. Has both an email and a phone number. There we go, down here. And I'm creating a function called invoke soon. And it's deliberately like passing null along as the lexical scope. And it's a little bit contrived, but I'm just trying to show you kind of how this works. So if we try to invoke this, we'll see that it's not enough to just pass email along, right? Like we have a string here that can be email or phone. No matter which one I pick, I still get a type checking error. And the reason is this constraint is not satisfied. We could solve this two ways. We could bind the function, create a bound version of the function. So we're behind the scenes, we're creating a closure around the function and ensuring that it's invoked with the correct lexical scope. Or we could use call and apply. And as of a very recent TypeScript release, it escapes me which one, you can enable strict type checking with bind, call, and apply. You don't run into this a lot, but now you understand everything you really need to know to get started with functions. And note that, of course, we don't, like, this appears to be an additional argument. You do not have to pass 2 arguments to this function. This function accepts 1 parameter still.